Bismillahirrahmanirrahim. Welcome to the Electrical Engineering YouTube channel. In this lecture, I am going to demonstrate single-phase induction motors. So, induction motors, as we all know, that work on the polyphase supply. So, if we have a two-phase or a three-phase supply, only then we will be able to produce revolving magnetic field in the stator, and that revolving magnetic field in the stator causes induced EMF in the rotor, and the rotor also starts revolving. But most of our supplies in our houses, in our factories, in our villages are single phase AC supply. So it is essential to be able to operate an induction motor for a single phase supply. Otherwise, the induction motors cannot be operated for domestic and rural applications. So in single phase, if we apply a single phase supply to an induction motor, it will always cause a pulsating magnetic field, which is not actually revolving, but it is a pulsating magnetic field. So pulsating magnetic field can also cause revolving the rotor, but in that case, we have to give the rotor a slight push, or a slight starting torque has to be applied to the rotor. And if a slight push or a slight starting torque is applied to the rotor, then pulsating magnetic field will be able to keep the rotor of the induction motor revolving. But if no starting torque is applied, then pulsating magnetic field will not be able to produce a starting torque in the rotor, and the motor will never be able to run from a stationary condition. So this single phase supply is actually not a self-starting application. So if we want to achieve self-starting of a single phase induction machine, we must have a two-phase supply. But for being able to operate the induction motor for a single phase supply, the internal winding of the single phase induction motor, or the internal winding of the stator of an induction motor, is actually made two phase. So first, in the first phase, the winding one winding is connected, and for the second phase another winding is designed. The first winding is called main winding, and the second winding, which is lying actually at 90 degrees with the main winding, is called the starting winding, which can be observed in this figure. So these slots and these slots correspond to the main winding, and these slots and these slots correspond to the starting windings, and the winding axis of these two windings lie at 90 degrees from each other. Now we have to keep the properties of these two windings slightly different, such that the current flowing between these two windings has a certain phase difference between them. So the main winding is kept more inductive, and the starting winding is kept more resistive. This can be achieved by using a thick conductor for the main winding, and more number of turns are used for the main windings. For the starting windings, the cross-sectional area of the winding is kept very small, or a thin conductor is used, and less number of turns are used for the starting winding. So as a result, the main winding will become more inductive, and the starting winding will become less inductive, and it will become more resistive. So this is the most fundamental type of the self-starting single phase induction machine, in which only the intrinsic characteristics of the two windings are kept slightly different to get a phase difference between the main winding current and the starting winding current. So whenever there is a phase difference between these two currents, or between these two phases, the revolving magnetic field will be produced, and it will cause starting torque in the induction motor. So this is the circuit diagram of the single phase induction machine. This is the main winding, this is the starting winding, and there is a series resistor for the starting winding, and we have a centrifugal switch over here. So single phase supply will be applied to this motor, and this is the rotor. Now, since this main winding is kept more inductive, so the current through this main winding, which is Im, is lagging behind the voltage. So this horizontal phasor is actually correspond to the applied voltage, and this Im is corresponding to the main winding current. So the phase difference between this Im and this voltage is very high because this winding is more inductive. Now this starting winding is kept less inductive, so the phase difference between this voltage phasor and this starting winding current is small. So we have a resultant phase difference between the starting winding current and the main winding current, which is alpha. So the I is actually the resultant current which is actually going, or which is actually entering the motor windings. So I is the vector sum for this uh, figure, and alpha is actually the angle between the starting winding current and the main winding current, and the starting torque is proportional to sine alpha. It means greater the phase difference between the starting winding current and the main winding current, greater will be the starting torque, and vice versa. So this S is actually a centrifugal switch, and the purpose of using this switch is to isolate this starting winding from the circuit when the motor comes to the running condition. So when the motor is running at 75% of the full load speed, this centrifugal switch will be opened. Due to the high speed, centrifugal force will be very high, which is actually applied to this switch contacts, and this switch will be opened, and in the running condition we will only have the main winding, and there will be no starting winding in the circuit. So when there is only one current flowing through the motor, the pulsating magnetic field will be there, and since the motor is already in the running condition, so the pulsating magnetic field will be able to keep the motor running. So this is the, again, this is the main winding, this is the starting winding, this is the rotor which is actually revolving, and here we have a centrifugal switch. And initially the starting winding is connected in the circuit, and we have higher starting torque initially. And at this point, when the motor comes to 75% of the rated speed, this centrifugal switch opens, and the starting winding is actually extracted from the circuit, and the running characteristic of the motor will start from this point up to this point. So there is a discontinuity between the starting torque and the running torque, and discontinuity is present due to the disconnection of this starting winding, which actually changes the overall characteristics of the system. So when this winding is actually isolated from the circuit in the running condition, we will see a discontinuity over here, and it is also showing that during the presence of this starting winding, this starting torque is high, and when this starting winding is removed, the overall running torque of the motor is actually reduced, and this is the running torque which is actually smaller than this profile. So in such motors we can also reverse the direction of rotation of the rotor by reversing these main winding terminals. So if this terminal is connected to the lower side and this lower terminal is connected to the upper side, then the direction of rotation of the rotor will be reversed, since the terminals of the starting winding are kept same. So here the motor is running in the clockwise direction, but now the motor rotor is running in the anti-clockwise direction. But if we reverse the terminals of the main winding and starting windings at the same time, then the direction of rotation will not change, and it will continue to rotate in the same direction. So that is the first and most fundamental type of the self-starting single phase induction machine. And in this case we not connect any capacitor, and the starting torque which is achieved for such a motor is also not very high. So this is the second variant of the single phase induction machine, and here we have actually connected a capacitor in series with the starting winding, and this type of motor is called capacitor start induction run motor. So the only difference between this motor and this motor is that we will have a leading current flowing through the starting winding, and this is the main winding current, but the starting winding current will actually be leading the voltage phasor, and the resultant current or the net current will actually be lying at the center of the starting winding and the main winding current, and this phase difference between voltage and current is actually smaller as compared to that for this type of motor. So in this case, the phase difference between this voltage and the net current phasor is phi. This angle is high, and in this case this angle is small because the starting winding current actually is leading the voltage, so this angle is reduced. And as a result, for such types of single phase motors, we have a better power factor. Since the current is lagging behind the voltage by a smaller angle, so the power factor has improved drastically in this case. And also the phase difference between the starting current, winding current and the main winding current is also high. So it is actually almost 80 degrees. And when we have a higher angle alpha, the starting torque will also be very high according to this expression. In this case, alpha is small, so starting torque is small, but here the starting torque will be comparatively high. So this is the circuit diagram, and here we have a main winding. This is the starting winding, and we have a capacitor which is connected in series through a centrifugal switch, and these are the characteristics, torque, speed characteristics of capacitor start induction run motor. So at start, this capacitor is connected in the circuit, and we have very high starting torque. And in the running condition, this centrifugal switch will be opened, and the running torque will be reduced, will be much smaller than the starting torque. So here we have a substantial gap between the starting and the running torques due to the presence of this capacitor. So this type of motor will offer high starting torque as compared to the first type discussed. Third type of the single phase induction motor is capacitor start and run motor. And the only difference between this capacitor start and run motor and capacitor start induction run motor is that there is no centrifugal switch in this type, and this capacitor will be connected in the starting condition as well as in the running condition. So as a result, for this type of motor, we will have a high starting and the running torques, and there will be no discontinuity between these two operating regimes. So the characteristic will look like this, and this characteristic is showing that we will have high starting and the running torques. So the fourth and final type of the single phase induction motor is a two value capacitor run motor. And this type of motor has actually two capacitors connected in parallel with each other, and there is a switch between these two capacitors. And again, this is a centrifugal switch, and this motor is actually operated when at the starting condition, both these capacitors will be connected in parallel into the system, and the combination of these two capacitors is actually connected in series with the starting winding. So at start, we will have these two capacitors. So this type of motor will offer even higher starting torque due to the presence of two capacitors. And when the motor comes to the running condition, this centrifugal switch will be opened, and as a result, only this one capacitor C1 will be connected in the circuit, and this capacitor C2 will be isolated from the circuit. So in the running condition, one capacitor will be connected, and in the starting condition, these two capacitors will be connected. So the parallel combination of these two capacitors will be C is equal to C1 plus C2. So at start we have higher capacitance, and in the running condition we will have only C1 capacitor. So it will offer even higher torque at the start, and so also it will provide high torque in the running condition. And that is all about our today's lecture. And this type of motor is actually used to start heavy loads, because when we have two capacitors, there will be even higher phase difference between the starting winding current and the main winding current. So hopefully you have enjoyed the contents of this lecture. For watching more similar videos, please stay tuned to this YouTube channel. Until the next lecture, it's goodbye.